Hello, this is your Algebra 2R trig review. First, we're going to look at using SOHCAHTOA and Pythagorean theorem. In this example here that we're starting out looking at, we are asked to determine sine, cosine, and tangent of angle R. So angle R is our angle of perspective, but before we can do much, we want to find this third side here, and we can easily do that using Pythagorean theorem. This is the hypotenuse. I know that because it's directly across from that right angle. So when I do my a squared plus b squared equals c squared, I'm going to take the sum of the squares of the two legs. It always has to equal the hypotenuse squared. So 5 squared gives us 25. 12 squared gives us 144, equaling x squared. Adding those together, we get 169 equals x squared. Square rooting both sides, we get x equals 13 for our third side. Now, relative to this angle of perspective here, angle R that was mentioned, this would be my opposite side. Right across from that right angle again is the hypotenuse, which means this is the adjacent side. So when we look at sine, and we know that sine is opposite over hypotenuse, we have sine of angle R, opposite, which is 5, over the hypotenuse, which is 13. Then we do cosine of R. That's the adjacent over the hypotenuse, so that will be 12 over 13. And last would be tangent of R equals opposite over adjacent, so that would be 5 over 12. And then we can use our SOHCAHTOA to find missing sides or missing angles. In this problem here, our angle of perspective is right at the 23 degrees, so directly across from that is the opposite side. Across from the right angle is our hypotenuse. The remaining side is the adjacent. The two sides that we're working with are A and H. That would tell me to work with cosine. So we're going to do cosine of our angle, which is 23 degrees, equaling the adjacent over hypotenuse, 18 over 18 over x. And then I can easily solve for x by putting that over 1, cross multiplying and solving. So we have x times cosine of 23 equals 18. So then to solve for x, we can just divide by cosine of 23 on both sides. And just make sure your calculator is in degree mode. And we divide that out. Should get 19.55 and then so on. For the next problem, now we're trying to find an angle. So we're going to use inverse trig. We're still looking at the opposite side and the hypotenuse, which tells us we're working with sine. So we have sine of our angle equals opposite over hypotenuse. And then we're not going to cross multiply when we're trying to find the angles. We're going to use that inverse trig. So we're going to do inverse sine of 10 over 14, and that's going to equal x. So on my calculator, give it a second. And we do inverse sine. You're going to use second and sine. That's how we get that inverse function, just going backwards. We're going to do inverse sine of 10 divided by 14. And we get our corresponding angle measure. Just be careful with rounding directions here. We don't have any rounding directions, so I'll just say 45.58, so on. In the next section, we talk about angles as rotations. So if you were to draw a 120-degree angle, well, we know this is 0, this is 90, this is 180, so it would be a little short of there. Would be right about there. If I draw that arrow showing the rotation, that would be a counterclockwise rotation, and that would be approximately a 120-degree angle. Now, if you have a negative angle measure, that just means you're going clockwise. So if I were to start here, we'd have negative 90, negative 180, we would go a little past there, and that would take us to negative 200, also in that second quadrant. Now I could have added 360 degrees to that. And if I do that, I get a 160-degree angle. And I could say that those two angles, those are coterminal. Those would terminate in the same exact position. Which brings us to the next section. It says determine a coterminal angle with negative 150. So I'm just going to add to that 360 degrees. And that leaves me with 210 degrees. Those angles would be coterminal. If I were to draw them, they would terminate in the same exact position out in quadrant 3. Next, when we look at the unit circle, any point on that unit circle, cosine corresponds to the x-coordinate and sine corresponds to the y-coordinate. So if I were to be asked to state what sine, cosine, and tangent are based on this point on the unit circle, well, sine of theta would just be that corresponding y-coordinate, which is radical 3 over 2. Cosine of theta would be the corresponding x-coordinate. Now again, this only works if we're on the unit circle, but since we are, we can just grab those values. Now tangent, remember, is the quotient of sine divided by cosine. So if we want to figure out what tangent of theta is, we have sine, which is radical 3 over 2, divided by cosine, which is 1 over 2. And at this point, I could keep change flip, or since I'm dividing with common denominators, I can just drop out those denominators. This would be equal to radical 3 over 1, which is just equal to radical 3. So that only applies if we're on the unit circle. In that problem, I knew we were on the unit circle because we had a radius of 1. Next, we have our ASTC chart, just tells you what's positive in each quadrant. So in this question, we're asked to name the quadrant where sine is greater than 0. That's another way of saying positive. And cosine is less than 0. That's another way of saying negative. So if we look at that ASTC chart, looking where sine is positive would be either in quadrants 1 or 2, 3 and 4 is off the table. And also where cosine is negative, well, I'm going to eliminate where cosine is positive, which would be quadrant 1, which means we must be in quadrant 2. If we look at our exact value chart, sine, cosine, and tangent of 30, 45, and 60 degrees. Remember, we use that little trick here where everything in the first 2 rows is all over 2. The order of the numerators is just 1, 2, 3, 3, 2, 1. And we square root the 2's and 3's. We don't square root the 1 because the square root of 1 is 1. And then tangent of 45 degrees is anything divided by itself is going to give us 1. So sine divided by cosine, that'll give us 1. And then I always say tall to small, radical 3 over 3 and small. Now we could divide those values, sine divided by cosine, to give us those tangent values as well, or you can just memorize the table. Now when I'm asked to find these exact values, that tells us we're either using the table or the unit circle. So sine of 60, we know from our table, is radical 3 over 2. Tangent of 60 is just radical 3. You could always put that over 1. plus cosine of 60 is just 1/2. So first I would multiply radical 3 times radical 3 is radical 9, which just gives us 3. So we have 3/2 plus 1/2 gives us 4/2, which reduces to 2. We have another exact value question here, tangent of 240. However, tangent of 240 is not in this table here. So what we're going to do is QRS that. I would do a sketch off to the side of a 240-degree angle. I know that's going to be in quadrant 3. Our reference angle is always going to be the distance between our terminal side and our x-axis. So we're either subtracting with 180 or 360. Never use 90 or 270. So here 240 is 60 degrees past 180, so that's my reference angle. And the sine, if we go back to our ASTC, that tells us in the third quadrant, the only thing that's positive is tangent. So we're looking at a positive value here. Putting those three pieces together, we get positive tan of 60. And then just going back to my table, positive tangent of 60 is just positive radical 3 or just radical 3. So for the next one, now this is currently in radians. I can easily convert that to degrees by replacing pi with 180. I like to think of 180 divided by 3 is 60, and then just doing 60 times 5 being 300. So we're looking at sine of 300. I would do the same exact thing, QRSing it. A 300-degree angle would be in quadrant 4. My reference angle this time subtracting with 360 degrees, that would be a 60-degree reference angle. And the sine, if I do my ASTC, the only thing positive in the fourth quadrant is cosine, which means sine must be negative. Putting my three pieces together, we have negative sine of 60. Going back to my table, sine of 60 is radical 3 over 2. So we'd have negative radical 3 over 2 would give me that exact value. When you are converting from radians to degrees, what we're technically doing is we're multiplying by 180 over pi. Now those pi's are going to cancel out, and we just multiply straight across. We'd have 180 over 4. Now most of you remember that shortcut. The shortcut is just replace pi with 180 because those pi's are always going to cancel out. 180 will be in the numerator. So when I divide those out, I would be left with 45 degrees. When we are converting from degrees to radians, then we're just going to multiply by the reciprocal, by pi over 180. And then I would just multiply straight across, 135 pi over 180. And then you're just reducing your fraction, but leaving pi as pi. So I can put into my calculator 135 divided by 180, do a math, enter, and that would give me 3/4. So 3 pi over 4. In this next function, we are asked to find all remaining values for theta given this information here. We have cosine is less than 0, which is a fancy way of saying cosine is negative. And we have cotangent is 8 over 6. Now I can already at this point fill in one of these blanks by saying cotangent is 8 over 6, which tells me I also know tangent, which is 6 over 8. And this deals with our reciprocal functions. Just a quick recap of those reciprocal functions. Secant is 1 over cosine. Cosecant is 1 over sine. I always say those start with opposite letters, the opposite of C being S and vice versa. Cotangent does not follow that rule. Cotangent is reciprocals with tangent, which is cotangent is equal to cosine over sine. So at this point, what I can do is draw out some information that we have. Now, I first want to establish what quadrant I'm in, where cosine is negative. Now remember, cotangent and tangent have the same signs. So if cotangent is positive, tangent is also positive. So if we go back to ASTC, where cosine is negative, I'm eliminating where it's positive. And then where tangent is positive, we would have to be somewhere in quadrant 3. So I'm going to draw my angle out here. And I'm going to make a right angle by drawing back to the x-axis. So now we know that tangent is 6/8. My angle of perspective always being closest to the origin. If we do know tangent is opposite over adjacent, my opposite side being 6, the adjacent side being 8, and we're back to having to find that third side and using our Pythagorean theorem. So I can quickly do that. I know the two legs, I don't know the hypotenuse. So we have an 8 squared plus 6 squared equals x squared. We have 8 squared being 64 plus 6 squared is 36 equaling x squared. That gives us 100 equals x squared, and square rooting both sides gives us x equals 10. Okay, so now we know the opposite side, we know the adjacent side, and now we also know the hypotenuse. So everything from here is very straightforward, just thinking back to our SOHCAHTOA. So sine being opposite over hypotenuse, I can figure out those values. That would be 6/10. Now I want to establish the sine. The only thing positive here is tangent and its reciprocal function, which means everything else must be negative. And as long as you're in quadrants 2, 3, or 4, you'll always have 4 negatives and 2 positives. Once I know sine, I know its reciprocal, which is cosecant. That would just be 10/6. I can figure out cosine doing adjacent over hypotenuse. My adjacent side is 8, hypotenuse is 10. If I know cosine, I know its reciprocal function, 10/8. So again, on this one, just be really careful. Probably one of the most common mistakes is making mistakes with the signs. So just don't forget to establish your signs. Look at what's positive in the following quadrant and go from there. Next, we look at our Pythagorean identities. Just a recap, tangent is sine over cos. I've heard that as South Carolina. Cotangent is the reciprocal of tangent, so cotangent is cos over sine. Cosecant is going to be 1/sine. And secant is 1/cos. Okay, so in this problem, we're given secant, we're trying to find sine. So if I go to the Pythagorean identity that has sine in it, I need to know cosine. Once I know cosine, I can figure out what sine is. Now, we don't know cosine, but I do know secant, and I do know that secant and cosine are reciprocals, which means cosine of x must equal 12/13. Now I know cosine, I'm trying to find sine. So I'm plugging into this identity here. Sine we don't know, so I'm just going to leave it as sine squared of x. Plus cosine of x we do know, 12/13. Don't forget that that is squared, and that's going to equal 1. So sine squared of x plus squaring each numerator and denominator, we get 144/169. And I'm going to rewrite this 1 as 169 over itself, so that when I subtract that value over, we have common denominators. So now we have sine squared of x. Subtracting over the 144 gives us 25/169. I want to get sine of x by itself, so I have to square root both sides. Don't forget, that gives us a plus or minus. So we have sine of x equals plus or minus the square root of that fraction gives us 5/13. At this point, we want to make a decision. Is this positive or negative? This is based on the quadrant information. We were told that our angle is somewhere between 3 pi over 2, which is 270, and 2 pi, which is 360, which must mean we're in quadrant 4. If I go back to my ASTC, the only thing positive here is cosine, which means sine must be negative. So we have sine of x equals negative 5 over 13. Next, we're trying to find what cotangent is given cosecant. So if I go to where cotangent is in one of my Pythagorean identities, and make sure you commit these to memory, I'm trying to find cotangent. So if I know cosecant, I can plug in and solve. And I do know cosecant in this problem. So we have 1 plus our cotangent squared of x is equal to cosecant squared. So 5 over 3 squared. I know that's going to give me 25 over 9. So I'm going to rewrite this one as 9 over 9. So that, again, I have common denominators. I'm going to subtract over that 9 over 9 to solve for cotangent of x. And then we just, again, square root both sides. Don't forget your plus minus. So we have cotangent of x equals plus or minus 4/3. Now to decide the plus or minus, remember cotangent has the same sign as its reciprocal function, which is tangent. We are between negative 90 degrees, which remember down here is negative 90 degrees, which is coterminal with 270 degrees, and 0, which is over here, which means we're in quadrant 4. If we do our ASTC, the only thing positive in this fourth quadrant is cosine, but we're looking at cotan, which has the same sign as tangent. So if tangent is negative in this quadrant, so is cotangent. So we have cotan of x equals negative 4 over 3. So again, just be careful of your signs. In the next problem, we have some trig proofs. Remember, we generally work with the more complicated side. So for something like this, I'm going to look at those reciprocal functions. I know cotangent is equal to cosine over sine. I know cosecant is 1 over sine. And for now, I'm just going to keep this as 1 minus cos of theta. My goal is to make this whole thing look like this other side, which is sine of theta. So at this point, I have common denominators within these fractions, so I can add these two together. Now I'm going to rewrite this numerator as 1 plus cosine of theta. You'll see why in a moment. All over sine of theta. So now we're taking that and we're multiplying that by 1 minus cos of theta. Now the reason that I switch that order, and I can do that only because this is addition, is that I'm multiplying at this point two conjugates. And when we multiply two conjugates, we can use that shortcut of just multiplying the first terms and the last terms. So 1 times 1, we get a 1. Positive times negative, we get a negative. Cosine times cosine is cosine squared. I'll write that a little neater. Cosine squared of theta. All over sine of theta. So now at this point, I know that 1 minus cosine squared is actually equal to sine squared. So that's going to give me sine squared of theta all over sine of theta. And then I can just reduce sine squared divided by sine is just sine of theta. And now we have sine of theta, which was our goal. So I can say I've achieved my goal and I'm done with that problem. That one was a little bit tricky, especially with those conjugates in there, but they're not always that difficult. On this next one, I can see that I'm actually multiplying two reciprocals together, which will give me 1. But if you didn't know that, you could easily just say secant is 1 over cosine times cosine. And now I can see I'm multiplying something by its reciprocal. Those are going to cancel out to be a 1. I'll do that after I bring down the cosine squared of theta. And my goal is to make this whole side look like the other side, which is sine squared of theta. So as I said before, these cosines cancel each other out. You have to do the multiplication first. I could multiply straight across and reduce, or I could cross cancel. Those cancel each other out. We have 1 minus cosine squared of theta, which we know is equal to sine squared of theta. I've successfully made it look like the other side, so that one you can see is much easier. In this last section, we're given a couple extra problems. We're given coordinates of a point on the unit circle. Your unit circle here is the big keyword. That tells us that our x-coordinate corresponds to cosine, y-coordinate is sine. So I can again sketch this out. If I go over a positive amount and then down, I can tell that I'm in the 4th quadrant. So that's going to help me because now I'm going to find this reference angle here. And if I can figure out what that reference angle is, I can figure out what theta is because that's going counterclockwise to that terminal side. So I can find out what this reference angle is using either piece of information, doesn't matter which one. I'm going to stick with cosine. So we know that cosine is equal to 1/2. So I could do inverse cosine on my calculator, or I could just think of on that chart from up above where cosine is equal to 1/2. If I scroll up, I can see cosine is equal to 1/2 at 60 degrees here, which means if I were to even type in my calculator and do inverse cos of 1/2, I would figure out that my reference angle is equal to 60 degrees. So if I have a 60-degree reference angle, I can figure out what my overall angle is by saying I'm going full circle but stopping 60 degrees short. If I stop 60 degrees short of 360, our overall angle is 300 degrees. And last, number 2 says the terminal side of angle theta in standard position passes through this point. So right away I'm going to draw it. I know I'm not on the unit circle because I don't have a radius of 1. These points are too big. We go over 14 and down 48, so that would look something like that. This doesn't have to be drawn to scale in any way. But I'm in the 4th quadrant. I can easily go to the x-axis to make that right triangle. Yes, you're always going to the x-axis. Here would be our angle of perspective. And we're going over 14, down 48. I'm not going to put negative 48 here because it is a distance and we never have negative distances. The negative just tells us we're going down. So we want to figure out what cosine is. Now we know cosine is equal to adjacent over hypotenuse. We know the opposite side. We know the adjacent side. We don't know the hypotenuse. So again, we're just going to use that Pythagorean theorem to find our hypotenuse. We have the 2 legs. So I'm going to do 14 squared plus 48 squared equals that hypotenuse squared. 14 squared, that gives us 196. 48 squared gives us 2,304. And when I add those two together, we get 2,500. We square root both sides. We get x equals 50. So now we know that third side, which is our hypotenuse. So we have cosine of our angle is equal to the adjacent over the hypotenuse. But again, don't forget to establish your sign. If we do our ASTC in the fourth quadrant, the only thing that's positive is cosine. We are working with cosine, so I know that's going to be a positive value. So that would be my final answer. So that's it for your trig review. Hopefully this helped.